I know a bunch of districts are shutting down. Baraboo, okay. I know our school district, the one that I'm from, Waukesha School District, I think they're doing 2 days on, 2 days off kind of thing. Um, but it is what it is. We're gonna get through this. Hopefully next year at this time, everything will be back to normal, and we can all, um, you know, go and visit our relatives and stuff like that during the holidays. It's going to be a weird one this year. All right. This week, we're going to be talking about finding inverse functions algebraically, okay? So that is the big concept this week. As I said, I took out one of the assessments this week, so you should only have one assessment this week. It'll be the multiple choice one. How do you find, I'm just going to give you how you find an inverse function algebraically. It's fairly easy. If I gave you something like y is equal to, I better turn my marker on so you can see what I'm writing, y is equal to 3x plus 4, and this is a very simplistic problem, but they're all done the same way. In order to find an inverse function, and let's talk about what an inverse, let's just find an inverse function. All you do is you flip the x and the y around. Okay, so I would rewrite this as x equals 3y plus 4. That is your first step. You just flip the x and y, and then your next step would be to solve for y. Well, if I was going to solve this for y, I would subtract 4 off. So I'd end up with x minus 4 is equal to 3y. And then my last step would be to divide through by 3. So basically, it's a lot of algebra. So my inverse function would be y is equal to x minus 4 over 3. That is my inverse function. What does an inverse function do? Well, an inverse function undoes what the original function did. So for example, if I told you in this original function, I said, hey, plug in positive 2. Put in 2 for x. Well, if you put 2 in here, 3 times 2 is 6 plus 4 is 10. So if you plug in 2, you get 10 out. Now, the inverse function, what it does is it flips that around. If you plug 10 in to the function, you should get 2 out. So if I put 10 in here, 10 minus 4 is 6. 6 divided by 3 is 2. That's an inverse function. It basically undoes what the original function did. Yeah, it really is. Well, this whole class is kind of a review of Algebra 1 and Algebra 2. Now, because you're going to see some of the problems today. Ooh, they're going to kick your butt. No pun intended. There are some tough ones on the practice this week. So let's take a look at those. So, and this is basically your notes from this week, what an inverse function is. And we can do the inverse function, but we just did the problem very similar to that. So let's talk about the practice this week. All right, so here is the Desmos presentation. Okay, and I'm going to say that some of these are going to, some of them are super easy, but there were 1 or 2 in there that I took a look at and it's like, wow, if these guys get this right, pretty good. All right, so let me, so you guys jump into the Desmos presentation. I'm going to hit sharing on here so I can see my lesson here. Okay, so I'm going to share that. All right, so what I want you guys to do is I want you to go to slide number 4. Slide number 4 is the first problem, and it says, use the property of inverse functions to find the inverse of f of x equals x plus 3. Now, really, when they give you something as f of x, when they say f of x is equal to x plus 3, sorry about that, I got to erase this because I hate when my graph goes all over the place. So when they write f of x equals x plus 3, that is the same thing as them saying y is equal to x plus 3. Okay, so we're going to use algebra to rewrite this as an inverse function. So the first step, rewrite, just flip the x and y around. So we get x equals y plus 3. And then we solve for y. Okay, that's not a big deal. I subtract 3 off from both sides. So I end up with y is equal to x minus 3. This is the inverse function, and this is how we would write it. We'd write it like this. This means inverse. So this is the inverse function of f, which is x minus 3. So my answer should be what? Letter C? Okay, so that was a fairly easy one. Okay, Okay. Arnish, the only thing you missed is we talked about inverse functions. How you solve an inverse function is you just flip the x and the y around and then solve for y, and that gives you your inverse function. Okay. So let's try, and I don't know if you have the link for the okay, I've got to go back because I don't think that is the link there. Sorry about that. I got to go back in and get the link for the Desmos presentation. Hit copy here. And there's the link. All right. So the first problem was fairly easy, okay? But as I said, they do get harder. I mean, there is no question they do get harder. So let's try some more. All right, so slide number 5, we have this one. It says find the inverse f of x equals 4x plus 20. Select the correct answer. Okay, so I'm going to let you guys do the work, and just in the chat box, just put your answer when you get the answer there. Again, this one is not one of the harder ones for an inverse function, but we will talk about all of them today. And for those of you that just came in to class, I was saying that please look at the pace chart from now on. During Thanksgiving break, I kind of condensed what we were doing. You should only have one assessment each week, and I believe most of the weeks they are multiple choice assessments. They're not the ones where you have to show work. So I am trying to make it less stressful for you guys. I know the holidays are a stressful time. I know it is a very stressful time right now in our country with COVID and everything going on. So I'm trying to take a little bit of stress off of you. Okay, so you should only have one assessment each week, and I believe they are multiple choice. You still have to do the practice, but if you come to the weekly main lesson, we go through all the answers. Okay, so Wesley said the answer is x minus 20 over 4. All right, so if I was going to do this problem, first thing I do is I'm just going to write. I write it out as y is equal to, because I was always taught that you have y is equal to 4x plus 20. Then they tell my next step is to flip-flop the x and y around, so I get x equals 4y plus 20, and then I solve for y, and that is my inverse function. So I'm going to solve for y. So first step, I'm going to subtract off 20 here. So I end up with x minus 20 is equal to 4y, divide through by 4, and that is my inverse function. So x minus 20 over 4. Where do I see x minus 20 over 4? Looks like letter C, doesn't it? Okay. Any questions on the first two? You guys okay with those? As I said, there's one or two of them that are a doozy. All right, let's try the third practice problem. Okay, a little bit tougher. Okay, I've got find the inverse function, f of x equals 1 over x plus 3. Okay, so try that one, and we'll see what you guys get for that. And when you get your answer, you don't have to write the answer in the chat box, but if you could just put the letter that you think it is. But it's a little bit tougher. Not one of the ones that I think are the doozies. That's coming up. I'm going to go into Desmos and see how you guys are doing. Okay, it looks like, ooh. Arnish, I love that step. Except now you got that X in the denominator. Oof. How do we get that out of there? All right. Looks like this is a little bit harder of a problem. So let's take a look. And this is how I would do the problem. I'm looking at this and I'm going to write down y is equal to 1 over x plus 3. Then it's like, okay, well, I got to flip-flop the x and y around. So x equals 1 over y plus 3. Okay, now I can rewrite this thing. I can cross multiply. So I end up with x times y plus 3 is equal to 1, because 1 times 1. Then I can divide through by x. Okay. And then I'd end up with y plus 3 is equal to 1 over x. I'm trying to get y by itself, so now I'm going to subtract 3. So I end up with y is equal to 1 over x minus 3. That's it. So my answer should be letter C. And I think I saw 2 people with that answer. Awesome. Still not the tough ones. All right. Any questions on that one? Anybody have a question about that problem, how we came up with our answer there? All right. Next one. I forget what the numbers are now. Okay, I think this is number 4 or something. Uh-oh. X to the 11th power. The one with E in it. That's the hard one. You're looking for the hard one, aren't you, Wesley? Thank goodness you're in the help session, or the main lesson, because we'll go through that problem. All right, now this one here, we've got x to the 11th power. How do you get rid of an x to the 11th power? Okay, so if I wrote this problem, I would go, oops, why isn't my marker not working? Y is equal to, no, let's get rid of that. Y is equal to x to the 11th plus 3. Oh boy, my marker's really going a little crazy. I'm going to flip-flop the x and y. So I have x equals y to the 11th plus 3. So I want to get y by itself. So I'm going to subtract off 3. So x minus 3 is equal to y to the 11th. Well, the only way to get rid of a power is to do a root. Well, you can do a root of any power. So I'm just going to take the 11th root of both sides. And that will cross off that 11th power. So the 11th root of x minus 3 is my inverse function. So that wasn't too bad. Yep, take the 11th root. Right. So that wasn't too bad. All right. Next problem. Uh-oh. Whew. This is the one that I said was going to be a bummer. Now, for most of you, you probably don't remember logarithms. Okay, and that's why when Wesley said this is just a review of Algebra 1, I'm not so sure you're going to get this in Algebra 1. But remember logarithms. What is a logarithm? Can anybody tell me what a logarithm is? Wesley, you should be able to tell me this because I had you in class previously and we talked about this. What is a logarithm? And I said, anytime you see a log, you should be thinking one thing. What is a logarithm? Okay, and for those of you, anytime you're dealing with a log, it really is an exponent. Logarithms are exponents. Most kids don't have problems with exponents, but when it gets to be a logarithm, it's like, oh no, I don't get how to do this. Well, a logarithm is an exponent. So for example, if I had something like log base 2 of 4. That is equal to 2. Well, we can rewrite this as an exponent. It is the base to this power. So 2 to the second power is equal to 4. Well, we can go backwards also. If they give me an exponent, I can write it as a log. So this would be log base 2 of 4 is equal to 2. Well, that's what this problem comes into. So if I rewrote this, this would be x equals e to the y squared. Well, I'm going to rewrite this as a logarithm. So this would be log base e of x equals y squared. Does anybody know what log base e is? There's another way you can rewrite log base e. Log base e is, and I got to jump back to the course. Log base e is natural log. That is absolutely right. So if now I can rewrite this because I have log base e. Well, anytime I see log base e, I just write natural log, and I still have that x there. So I have natural log of x equals y squared, and then I'm just going to take the square root of both sides. So y is equal to the square root of natural log of x. All right. That I thought was a tough one because you have to remember so many different things. You have to remember that a logarithm is an exponent, and you can rewrite exponents as logarithms. You have to remember that log base e is natural log. Okay, so took rewriting inverse functions to a whole nother level. So it is letter D, yeah. Yep. It is D. All right. That was a tough one, I have to say. I didn't think too many people would get it. This one is an easy one. Okay? What is the inverse? If f of x equals 3x, what is the inverse of that function? One-third x. Okay. So letter C. So if I was going to do this problem, first thing I'm going to do is I'm just going to rewrite it as x equals 3y, divide through by 3, and I'm done. The inverse function is x over 3, or 1/3 x. Both of them are the same thing. All right. I'm going to let you guys do this problem. I've got f of x equals x to the 5th. What is the inverse function? I'm going to go into Desmos and make sure you check and see if you guys got this. Yeah, and some of these there's just not a lot of work to do on them. Some of these you guys can do in your head, and you know, with the assessment this week when it's just multiple choice, you can just do it in your head. I mean, you do not have to show work this week. Okay, so if I was going to do this one, I'm just going to rewrite it as x is equal to y to the 5th. Well, the only way to get rid of a y to the 5th is to take both sides to the 5th root, because that just crosses out. So I'm left with the 5th root of x. Done. That is it. Should be letter B for my answer. All right. Find the inverse function. G of x equals x to the 7th minus 4. What is the inverse function of that? Letter D. x minus 4 to the 7th power. Oops, I'm sorry. I'm reading letter E there. The 7th root of x plus 4. That looks right. And was there much work that you had to do there, Wesley, or could you do that all in your head? Yeah, I mean, because you've got that minus 4, so you're just bringing it to the other side, which would give you x plus 4. You got the 7th root, so I'm just going to take the 7th, or you've got the 7th power, so we're going to just take the 7th root. So I would agree 100%. Yeah, I agree with you. Yep, because it's just basically rewriting equations using algebra. That's all we're doing. All right. How about this one? I mean, can it be done in your head? Yeah, but there's a couple steps in this one. I would assume that this one you might want to write down a little bit. I would have to. I don't think my head works that way. But take a look at this one and then see what you get. Okay, I'm going to take a look at Desmos and see how you guys are doing. The reason you see a comma in this one is because the domain has to be set, because you can't plug every number into this function, because if you put a number greater than 3 in here, you would get 9 minus 4 squared. Well, that would be 9 minus 16. 9 minus 16 is -7. That is an imaginary number. That's why the only thing on there, the comma, is just saying that, hey, you can't use numbers outside of this domain. So they're basically just telling you what the domain is, because if they didn't, then because you can't use every number in there, it's just not it's not correct. So those commas in there are just the domain. So don't worry about that. Just look at the function. Okay, so the function in this one, we have the square root of, so I'm going to rewrite this as x equals the square root of 9 minus y squared. Okay, so the first thing I'm going to do is I'm going to try to get rid of the radical. So I'm going to square both sides. So I end up with x squared is equal to 9 minus y squared. Okay, I'm going to get rid of the 9. So I'm going to subtract 9 off of both sides. So I'm left with 9, or x squared minus 9 is equal to negative y squared. Well, you got to get rid of that negative, so I'm going to divide through by -1, which is going to change both of these. So that's going to be negative x squared plus 9 is equal to y squared. And then I'm going to take the square root of both sides. So my answer would be the square root of negative x squared plus 9. So does that look like letter A? If I'm looking at it correctly, does that? Yeah. Any questions on that one? Any questions? I mean, that was a little bit tougher because there's a couple extra steps in there that you have to take. You guys okay with that? All right. This one here, we have, says determine whether the function has an inverse function. If it does, find the inverse functions. Well, an inverse function, you can find, arithmetically, you can always find an inverse function, but in order for something to be an inverse function, what has to happen is the horizontal line test has to work. So um, in a problem like this, what you want to do is you really want to graph the thing out at the end just to see if the inverse is a function. And what do I mean by that? Well, when you look at something like, for example, is this a function? If I drew a circle, is this a function? Well, no, because we learned that the vertical line test says that if the vertical line touches the function in one place or in more than one place, it's not a function. Well, there's something that's called the vertical or the horizontal line test. If you graph out x plus 3 squared, okay, which looks like this, and if a horizontal line touches it in more than one place, then it does not have an inverse function. Okay, and why? Because if you found the inverse function, it's going to look something like this. So the inverse isn't a function, and that's basically what they're saying. It says determine whether the function has an inverse function. Well, if I just did the horizontal line test, right away I know that it does not have an inverse function. So could we find, could you use algebra to find an inverse function? Absolutely, you could. Okay. The only problem is that a function? And that's where it gets a little tricky. It's like, is the inverse a function? And that's where, you'd have to say, no, it's not a function. Because, and if you graphed it out, the vertical line test wouldn't work either. So that's kind of an interesting one to look at. Oh no, I I am lying to you on this one. I did not see the domain. The domain is just when x is greater than or equal to 3. That changes it. Then we're only looking at part of the graph. We're only looking at this part of the graph. So if you did a horizontal line test, it would only touch it in one place. Oh, so this one, yeah, it does have an inverse function. And the reason is because the horizontal line test only touches the function, the original function, one time. So yes, this does have. Now, if they did not put that domain, if they did not restrict the domain, then the answer would have been no. But they restricted the domain, so we're only looking at part of the graph. I apologize, I did not look at that domain in the beginning. Okay, so we have to find the inverse function. So I'm going to rewrite this as x equals y plus 3 quantity squared. I'm going to take the square root of both sides. So the square root of x equals y plus 3. And then I'm going to subtract off 3. So square root of x minus 3 is equal to y. So that is kind of a tricky question there. So the square root of x, why are there e's in the answers? I'm really getting confused here. There's no e's in the... What the heck is going on here? I think when you see an E in the answer, just get rid of it. I don't get why there's an E in the answers. That doesn't make any sense. Wow. I apologize to you guys. That is a really crazy answer. I don't know where the E's came from, unless the original problem was supposed to be y plus 3e. That's the only thing that makes any sense, but it doesn't look like it. Huh. That is the only thing that makes any sense here. There was supposed to be an E behind the 3, because then my answer would be letter A. So that is really A weird question. Where does the E come from? Just magically appears. I don't think that is true. Sorry about that, guys, but the answer should be A. I just looked at my answer key. So they must have just left out an E when they wrote the problem out. Sorry about that. All right, onward. The assessment for this week. It's not like this. When I made out my lesson for this week, I did not change anything. So the assessments for this week, or the assessment for this week, is not like what I have in here. The assessment for this week is just one multiple choice assessment. It is, but I did add a few extra problems because usually they're just 4. I did add some extra ones. So and most of them are just, basically finding the inverse function of a problem. Okay. Any questions on what we went through today? All right. You guys have a great week, and hopefully we'll see you back next week. Bye.